Okay, so we went through the process of bringing the drawings in. Quick review, starting off with the view palette. Make sure that you can use the dot 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 to browse to your file locations, your part or assembly. Um, the refresh, if something is already open but it's telling you that it's out of date, then you want to refresh to be able to get back in. And one of the reasons it'd be out of date is we went to sheet 2 and we brought in um, the next piece, and it's keeping me the center and the upper, and each time we bring in and it changes, then it's going to pull that information. I did not tell it to import any annotations, design annotations, dim expert, include items, and from hidden features. Auto start the projected view. Once you place the first item, that's what's going to take you directly into projected view, so that you can drag out the additional views. So I missed on this one the isometric view. Not super critical, but I'll go ahead and put it in projected view, drag it off to the side, and we'll go ahead and select. Maybe a little on the large side. So let's see, we're at half scale. So if I go over to custom scale, oh, went the wrong way. How about 1/4? May have to pick out a custom user scale to make that a little more functional. All right. So we had put marked for drawing items on this. So we'll take a quick look at the model items, and the source is the selected feature, the entire model. So I'm not, we know that there was a limit dimension on this arc, so we'll go through and figure it out. Let's see, I got it up on the other screen here. All right, so by default, we're going to bring in items that are marked for drawing. All right, so at the very beginning, when we went through the options, one of the things that I unchecked was mark all dimensions for drawing. So that's why a lot of my part files, when you go into a sketch, they're purple, not black. Right, the marked for drawing items are in black. And so when we go to this model items and I tell it to insert, then it's going to bring in that additional information. We can always go back to not marked for drawing. So things that, everything that was used to create, and we'll do a couple examples of each. Instance revolution counts, tolerance dimensions. Let's see what happens if we just do the tolerance dimension, because that may negate having to do marked for drawing or not marked for drawing. If we apply the tolerance, and that one comes in. Whole callouts. Well, yeah. Let's see if we can bring in the whole callouts for the front. The whole wizard locations. Don't really care about the whole wizard profile. Yeah, let's try. We'll change that up, because most of the time I'm in enough of a hurry that I just go marked for drawing, insert, done. Let's see, annotations. Well, I only picked the one part to put the grind symbols on, and I don't think it was this one. Let's see, what else do we have? Reference geometry. Nope, not concerned with planes. Coordinate systems. Nope, nope. Hidden features. No. And these are going to go to the dims layer. All right, so let's see what comes in. Hopefully something. All right, so I'll take the quarter 20, and the reamed hole. And we'll kind of rough position those. Let's see, so we still need to be on this one. Back into the model items. We'll clear those out and go to the marked for drawing. No dimensions are inserted. So I would have sworn there was at least a couple. So either I didn't place them when I was doing the initial. Oh, that was the 0.625 number. And that was the one that should have had the limit. So its maximum material condition would have been 0.5. And since everything is in purple, then going back through the diagnosis, I'm expecting it to be there, but I obviously did not do it. All right, so if I don't apply it, then I can't really expect it to get in there. All right, so we're going to go back. Let's see, tolerance, limit dimension minus 0.005, and accept. And then this becomes a mark for drawing. Go ahead and accept, save, and should be able to close. All right. So back to the model items. Let's go with the tolerance dimensions first. All right, so nice two-place decimal on that one came in. So not real overall functional there, but it did make it. So I'm going to undo the move and then undo the insert, and then the other option would be the one that I marked for the drawing, and it does pretty much the same thing. All right, so for our editing the document units, let's go to 3 decimal places. All right, so 201, 812 deep, those all look pretty good. And we have the dimensions. All right, so smart dimension on the edge, we can go through and put in some of those overalls. Let's see, the center marks. Let's go ahead and finish out the annotation. So I'm going to switch over to center layer, go into my center mark, and pick the 2 arcs, and then accept. And then back into the dims. All right. At some point, you will want to try, or you will have already tried, the, let's see, where is it? Well, I was thinking on one of them, maybe in the parts. Here we go, tools, dimensions, and under, nope. Maybe I am thinking of the parts. Okay, now we'll come back to that one. All right, so overall, a couple of locations. All right, so basically difference between our baseline, let's see, what are our 3 dimensioning styles? The ordinate, baseline, and chained. And the reason why we don't often use chained is because of the accumulation stack up of tolerances. So I picked this as my datum edge. If I stay with that datum edge, then I go to the center, that becomes a baseline. Right? So everything's off of the same reference. As opposed to chain, I can go between the 2 center marks. Well, I guess it would help to be in the dimension. But I'm setting myself up that even at the plus or minus 5 that I put over into the dimensioning, that this whole this slot location, the center location, could be out 10 thousandths and still be an acceptable part. All right, so doing the baseline dimensions kind of eliminates that that stack up and says that this one is independent of this one, and this has a tolerance of plus or minus 5. This has a tolerance of plus or minus 5, and can only exist within that that group. So theoretically, if this one went to a plus 5 and this one was a plus or minus 5 in relation to this one, I have the accumulation of both of those plus 5s or both of those minus 5,000s that it can go out of position. And so be careful when you're making those selections on your dimensioning styles. So let's see, we have an overall, and we'll go to its position. Getting kind of busy on the bottom, so let's go to the outside edges. Height-wise, and let's see, we have the centers, so we do need a width, and for a ½ inch plus or minus 5,000s plus or minus 10,000s really isn't going to matter for a ½ inch screw to go through into that slot. So this may be one that we can switch back to a 2-place decimal. All right, it's warning me that I changed from the standard tolerance, and because I want this to pick up 2 places, we can either come up to the little pop-up, and I can type in 2 times, or once the dimension is selected, and most of the time this is what I do, is come over to the dimension, type in, and once you, first couple times you modify, it'll come up with that warning, hey, you're modifying a dimension. Don't mess with the brackets or the less than greater than symbol, because it will mess with the linking. And other than that, after you see that a couple times, go ahead and say don't show again, because it gets kind of annoying after a while. Let's see, so radius wise, we'll probably just put in a note for the radius to pick up, and that can just be R, or full radius, or something that denotes. And same type thing, except this being an annotation, we're going to double click, and 2 times full radius. Yeah, it doesn't look, if it was just the single. So all right, some type of notation. Now the difference is that for this annotation, I'm responsible for any information that I put in there. So if you plop in annotations, that's one of the reasons why I don't like when it does the whole. When we first inserted these views, it came up with the annotation quarter 20 for the whole description. That doesn't do anything because it isn't related the way that the whole callout is. Right, so the whole callout is picking up the whole wizard information, is picking up the feature information to generate this callout. The other annotation doesn't really help us that much. All right, so let's see. We've got those in. We do need a radius, so kind of put that in. And if you haven't noticed already, I am not a strict ANSI standard, ISO standard. It needs to be readable and manufacturable. All right, so if the company standard is you need to be ANSI Y 14.2000 whatever, then sure, I'm going to spend about at least 10 more minutes going through and checking my drawing against the standards. I will point out one of the tools, and I can't find it because I don't use it. There we go. You can set up rules, and the design checker will go through this drawing and tell you whether you are following the rules or that there are, but it's another one of those, you have to invest the time up front to go through that process of setting up, so there's the learn checks wizard, building checks manually, checking against an existing file or an active document. That will go through and say, are you loosely or tightly following the standard? Is it working? Is it functional? Right. My feeling is that within the company standard, the machinist, the machine shop, putting these drawings out to quote, to estimate in other shops, they're going to communicate with their preferred the information they like transferred. Right. So again, if I can make it from this drawing, my personal feeling is if I can make it from the drawing that I've created, then I should be put it out there, and something's going to get missed, something's going to get overlooked. It's a matter of time. It's before you can't catch everything all of the time. So that being the case, we're going to put in the best effort on the working drawing on the documentation, and either in the process of redline review. Hopefully it doesn't make it to the machinist before it gets to that point, but often it does. Or the machinist comes up with a good suggestion of, hey, I'm holding it in the vise this way, and this number, whatever we decide to do, this dimension may be a good inspection dimension, but it's not a good manufacturing dimension. We don't know that until we get to that point of it actually going into production. All right, so be open to those suggestions, and ideally we have a methodology inside of the company, inside of the organization, that says when it hits that downstream, they have a way to communicate either directly back to the engineer, back through the machine shop manager, some way to make sure that that information just doesn't fall off the edge of the earth. All right, so I'm thinking that these need to be kind of down here. And the fun part with some of these dimensions is, especially with the angles, is getting them positioned and keeping them in place. Because this is near side, far side, I have to make a choice. Right there, again, my preference is I'm not going to include hidden lines unless there is geometry that it can explain. To me, this is a much cleaner drawing. Once I come over and, oops, didn't mean to close that. Once I come over and I say hidden lines shown, well, it's a little more detail, and would save some confusion on this one. I have to decide if that is of value to me. All right, so in this case, it is. I think that would be a good way to go. And there it popped back up. We made a change, so I click on that. There's my selection. It goes to note. It's an annotation. It's not a whole call out. So typically I'll pull those out. All right. So the near side, far side call out, it's still going to need something. The hidden lines support that. All right. So the isometric view, it doesn't need, so we can turn off the parent style. And actually there's a sketch showing, or I have something showing for the locating points. Yeah, those aren't deal killers either. So, all right, so we have this dimension. Maybe this, like I said, that is an inspection dimension. From its location, we need a radius. And I'm not thinking what the better would be, but that'll get us something to start. All right, so we're spending a little time with this one, and we get to that stage where on our drawing the ground surfaces were marked with a G, and really was not called out and I haven't thought through the geometric dimensioning and tolerancing. So going through the straight tolerancing, we kind of get it to a point as far as we can take it, and then decide what kind of GD&T we'd like to put into the mix. Also, with the grind symbols, we need to come up with a direction. So did a quick search for surface finish symbols, and we picked an understanding, and what the symbols indicating the surface requires material removal, indicating a surface that does not require material removal, the locations of all those. If I were to sit down and fully put the surface symbols on this drawing, I would have to have this as a reference, because these are things that if you just aren't doing it every day, they're not going to be apparent to you. All right, so meanings, explanations, and then the other one was from the University of Iowa, surface texture and machining symbols. They bring up the good point. What was the initial process? Was this machined? Was there additional material, cast, forged? Smooth, rough, and patterning. Going through the various processes below. Let's see, can't read it too much, but once you get below about 16 micro inches, then you're getting into those special processes, grinding wheels, electroplating, or let's see, what is the other one? Nope, those are still pretty rough. Anyway, electrofinishing, electroplating, going through the those extra processes to get those really fine surfaces. Symbol locations, yeah, older style, and materials, and then basically the same thing we just looked at. So different, same information, maybe slightly different format. Find something that makes sense to you. I always say that if you still have your technical drawing books, hold onto those. The engineering graphics books have those documents in them. They're good to keep around. All right, so we're putting the surface finish on this, but we haven't really done the build-up. So we looked at direct editing, well, within the last couple classes of I want to do a build-up of grind material, or from the let's see, did it still come up? So you know, at what point do I need to make a machine drawing and then a finished drawing? So at that point, I could go into the configurations. I could say I need my default will be the machined, and then I will create a configuration for grind. Well, might as well just go ahead and do it. Add a configuration for grind, and what this is going to do is these are our finish. The default for machined are going to be the built-up surfaces. So under direct editing, we can move the face. And when I move that face or add that material, what is it going to do to this this top face? Well, this is kind of irrelevant. As far as its height, really we're interested in this curved surface. So we do have to put a little thought into what that buildup is going to be. All right, so 100 thousandths, no, maybe 10 thousandths for grind. Right? And then this wheel is going to have to be set at the diameter and move back and forth, or we're going to need a really big wheel and have that surface so that it can move back and forth as we go down. All right, so what is our grind process even going to look like at that point? All right, so we built that out 10 thousandths, and one of the advantages of the direct editing again is that, let's see if I go 10 thousandths there, is that this shouldn't have any real ill effect on the mates, on the going through the model. So I may have got that backwards. Let's see, grind machine. Well, if this is already in the assembly, my default, I just built up. So I think I want to reverse that. All right, so font. So I'm going to switch that over to machined. It doesn't really matter the order. That's going to be right in the way. And we'll suppress that. Go back over to machined. Unsuppress that. Oh, yeah, it's telling me that I changed since I changed the name. All right, and then we want to check. All right, so since this is already in the assembly and I built it up through the process, I needed to reverse my logic. All right, so this shouldn't have changed. That didn't change. I go back and pick up, let's see, on that reference configuration, this goes over to machined. So that jumps up to 510. Well, in this case, for my base drawing, this doesn't help me. All right, and the radius of 1.9, if we're roughing this out with a plus or minus 5, my worst case is I have 5 thousandths of material to remove. Or my other worst case, or my max min condition, says that based on this dimension, I have 15 thousandths of material to remove. If that's acceptable, we go on. All right, so let's pull this up, even though we'll link that to the parent, even though there shouldn't be anything in this view. And actually, now that I think about it, there is. The front and back face also need to be ground. So we're going to have to go through this process of evaluate, adjust, make sure that I'm not missing anything. So back into the saddle, and we'll go one more time. Now this should be pretty interesting because of the radius, and so we're either going to end up with the truncated radius, or it's going to stretch the radius out a little bit. And either way, we still have to make that that decision on how that's going to play out. So I think I'd rather have the radius pushed back if that's the issue. So on the tolerance scheme, going through the analysis, this needs to be an open tolerance, plus or minus 10. If we're going to add material to remove later, then we know that this is going to be foreshortened a little bit once we go through the grind process. I'm not going to expect my CNC to put a little step in there so that I have the grind capability. All right, so 10 thousandths, build out. Try reducing the specified distance, angle, or changing the direction axis. So may have made that a little too complicated on the radius. Should have thought of that one a little sooner. Now, because of the flatness and what that is doing in locating our the upper and lower. Let's see which ones were those. Go back because it's just locating. That may be okay as a machine surface. It may not need to be ground. It just needs to be flat and perpendicular. So an inspection may be okay, but the tolerance isn't. Well, I say that, and then how tight is the tolerance? So it was plus or minus 1.5 thou. If the surface roughness is not an issue, then I would think that we could hold plus or minus 1.5 thou, 2 thousandths without that much issue. All right, but this dimension, this 3503, was one that wasn't applied either. So it needs at its maximum material condition, it needs a limit dimension, and we're going to go to 0.003. So if I catch it out of the part, that would be a good place to apply it. But ultimately I'm going to be able to apply it in the drawing as well. I do not. Well, we can check real quick. I was going to say I don't believe that it goes back naturally. So the 3503 maximum material condition, that doesn't. We're pushing the tolerance to the drawing. In this case, it's not associated back to the drawing, so be careful with that one. All right, what else do we have? All right, the overall length, position, well, center in relation to the pins, because they had on their drawing that the pins should be drilled through the lower at the same time. I think we can hold that position, but yeah, we can hold the position for the plate, and then the rotation, if that is slightly off center, it's really the let's see, let's get over to. It's really the arc, and that has about 10 thousandths. So we need something that controls the position of the arc. So that being the case, let's go with another center mark, and we'll put that in position. A little more than I would have liked, but let's go ahead with the document defaults. The mark size, the center is 100. If we turn off the extension lines, well, that puts it to the center. Would kind of like to have had one of those, but since it's not there, let's see. Let's go with the standby from the sketch. Oops, I think I missed. No, I missed. And we have the same relations that we can pull from the drawing. Let's see, move that over and relate. All right, so we had 10 thousandths on our position. Well, I'll go back that way now. Oh, and I still didn't get my near side, far side dimension in there. All right, so off of our datum reference, let's go ahead and since that is a locked position, it's still going to ask me, do I want to make this dimension driven or driving? So it will override back to the part. Most of the time it's going to be a driven dimension. Let's go with a position. Let's just say I want to make that a little bit tighter for location. So we'll make it a symmetric dimension with 2 thousandths. All right, just to show that it's critical. I haven't really done a stack up or anything to really to be able to pick that one. All right, so coming back, I finally got back to this one. Let's go to the end, and then there's the manually altering. Don't show again. Yes, continue. And then doing what they don't want me to do, I'm going to Control X the instance count and go down one level and go down one level, and then I'm going to grab all of that and copy again. Let's see, double check that I can spell. And then pretty much the same thing. Oh, what I wanted to try was, let's see, will the whole call out? No, the whole call out doesn't come up with the little pop-up. So go to the end, paste, and then I'm going to remove the primary so that those take place. Those can take precedence. All right. There again, that's something I would have to pull up and say, well, is that to our standard? Is it going to make sense, or do we need to to adjust the locations? Okay, so we have the oversized material. So this is basically our machine drawing. I'd want to make a note of that, possibly in our location, title block data. Let's see, let's grab the annotation. Oh, didn't do something. Inner values in the highlighted title block fields. You know what? I bet I didn't put an annotation in there. Left it blank. So something I had to go correct on the sheet format. One of those fun ones. You try it out. You see what you get. All right. So there would be a note over here for this is the machined, and then we'll have or pre-grind and then a grind for inspection for tolerance. All right, so that's the location. That gives me that. Okay, well, I'm sure I'm missing something or missing a couple of somethings. As far as the grind, so that I don't have to reproduce this whole thing, is if I right-click and copy, and right-click and paste, it should ask me where I want to place the paste. And we're going to go after the selected sheet. So I get a 1 dash or 1 parentheses 2. All of those were linked to the parent, so we go back to the default. Hit OK. A lot of these dimensions are not going to apply. No. Now we can go back and do the marks for drawing, or if I did not pick it up, then we'll go to distance, min condition, and that was back to our values, and the minus of 0.005. Oops, I think it's just 0.05. Okay, so for its location. So since that's post machined, a lot of these can go away. Referencing the grind dimensions though. All right, so here we're back to going and finding the surface. So let's see, machining required, so that's going to help. Machining prohibited. Basics, so different standards, and then all around. Well, we're not going to give it an all around. All right, so machining required, and not going to go through and pick out all of those items, but we are going to pick up the grind on that face. Let's see. There's the angle. Oh, perpendicular reversed. All right, so 180. And so those will be our two grind surfaces with their finished dimensions. To position. Okay. And locate that one a little better. All right, so let's take one more look at the symbol. And importance of giving it an upper and lower is if you don't want a finer, so O-ring surfaces that need to bite into the wall a little bit, you would want to limit the upper and lower 63 to 32. Otherwise, it's assumed that if I can go finer than 13, or if I can go finer than 32 or finer than 16, I'm going to from the machining process. And so if you put a symbol call out of 16, or sorry, 32, and my machining process gets it to a 16, but you don't need a 16, and it's actually going to be detrimental to the assembly, then I need that lower number so that I can adjust my machining process to match a desired. All right, so in this case, the 32 or better, between 32 and 63. Certainly a lot more that we can get into on the symbols, and next time we'll need to pick up the GD&T from for some of the other parts. All right.